Hello. Question 6. I've done all of it, and I want you to check your work with this. I'll be looking at it as well. Some of you may, if you didn't get this, may have to redo it because I want this to be really nailed on. It's guaranteed to come up in the exam, so we need to be confident with this. Now, it's a really difficult one for me because there isn't a set process, as I've explained to you already, of what you're going to be able to do to get these right. You've got to just have techniques in place, and things you're going to try, and it's a lot of algebraic manipulation, really. So I'll go through these. Quick note on questions 7 and 8. I'm hoping that you can tackle those having looked at some of this. The answers for 7 and 8 look okay to me. I did a video for question 9 yesterday. So I'm going to go through 6. The answers to the way I've gotten there isn't exactly the way that the answers have done it, but that's fine. I don't necessarily spot the same things as the examine as in the solutions that they do. So looking at the first one, then I'll try and be brief, and you can just look at it. But in here we've got a tan and a cot, so and they've been added together. So if they're the same trig type, so tan and 1 over tan, expressing it as a single fraction here is probably going to be quite useful. So that's something I would try. So if we think about the cross, if that's tan theta over 1, we'd cross multiply and add, and then we could express it as a common denominator. At that point there, we've got sec squared over tan, and then we can expand these. Well, actually, I've sorted it out. Sec squared as being 1 over cos squared, and tan being, 1 over tan being cos over sine. Then it expands, and then it looks like it simplifies. B, some of these are really, really painful, to be honest. Quite a lot of working out and steps. Some of these you wouldn't get necessarily in an exam, but if you can understand these, you should be able to cope with anything the exam throws at you, because as long as you know the identities. So B cosec over, so again we've got this situation where we've got cosec plus or minus sine x, where it's sine and sine, and so a single expressing that denominator as a fraction with a common denominator is probably going to be quite useful. So we've got cosec here over this. Then I'd be thinking, well, 1 minus sine squared x is cos squared x. And you basically try to reduce the terms, and you want to get to a point, ideally, where you don't really have minus and subtractions and additions. You've got multiplications and factors, because once it's all factorized, things start to cancel, and you can work with it quite easily, more easily. So just checking if there's anything going on here. So okay, so you know the flipping times, so I'm using brackets carefully to have this not as a fraction and a fraction, but as a multiplication of a fraction by flipping in times in. At which point, if cosec is 1 over sine, the sines cancel, and I'm left with 1 over cos squared, which gives me my sec squared, so that one was there. Okay, so again, brackets, so the first thing I try is just to expand the brackets. Pointing out that sine x cosec x is going to be sine x times 1 over sine, which is just 1. So that 1 minus 1 is cancelled. That's why I've jumped straight to this step here. And then we've got this, again, this situation where we've got 1 over sine and sine. So as a common denominator, that would be useful to have it as 1 minus sine squared x over sine x. And that means that we've got cos squared x. And then this kind of thing is quite a crucial skill. You've got cos squared over sine x. Remember, we've got the answers. We know what we're working towards, so that's often quite useful. Here we're trying to get to cos x. So there's two terms that I'm going to have to finish up with, multiplied together. So I'm not going to get that from here. So I'll be thinking, how can I separate something out so that it's going to simplify to give me two things multiplied together? So we've got, and then a classic is to break up a cos squared or a sine squared or whatever, so that it's cos x times cos x over sine x. At which point we can think, well, cos over sine is cot, and then we've just left with cos. So it does simplify to cot cos. D, I think, is the worst one. There's a lot going on. So instead of writing it all out every single time, I've basically, at the right side, detailed what's been swapped out at each point. So I'm just having a look now. So we've got cos squared over sine squared. So yeah, I didn't want to write out the numerator all again. So I've just done a little side note that cos squared over sine x in a few steps can be written as cot x cos x. Similarly, cot x sine x. Here, cot x sine x would be cos x sine x over sine x, which is cos x. So you might look like I've jumped the gun here, but on the right side, I've clarified what's gone on at which point. That was a particularly difficult one. And as I say, the answers may have got there in fewer steps, but I just sat down and started doing these. So I've just gone with my sort of standard approach of writing stuff down, making sure the algebra's correct, see what's what, and yeah, just making it work. So what I mean by the standard steps, expanding brackets, changing cos x to 1 over sine or cot to cos over sine, all these things because of the list of identities I've got that might help me get to an answer. So I'll let you look at that. I hope you should ask me if you ask me specifics about any of this stuff, even if it's just, oh, how did you get from that step to that step? I think that's how it's going to have to be, because we need to move on Friday. But the more practice of this we can be doing, the better. This is actually one of the times where I wish I was sort of in class with you all, because actually, I mean, don't go. I wish we were back in class, full stop. Don't worry about that. But this topic in particular would be a great whiteboard exercise, and I could quickly see what's going on, just to really sort of refine these skills. But so it's going to be a difficult one for people to get with, because we're just doing it remotely. I think E was okay. We've got a difference of 2 squares here, so in fact you can see where I've sort of gone down a rabbit hole. I'll just grab a pen here. Yeah, so I didn't tried something out, didn't work. Well, I spotted that it wouldn't really work, and then got rid of it, started again. Well, not again, but from the previous point. So there's not really much to say other than just noticing things like that, putting them over a common denominator, using your identities, changing cos x to 1 over sine or cots to cos over sine, all that business. And then actually F I thought was the easiest. Yep. Okay, so do questions, maybe do some of those again. Check out the textbook, there's been more practice examples for you to have a go at. As well as I'll check your work anyway, but 7 and 8, you could have a good go at those. Those are exam style questions. Hopefully that's been helpful on a difficult question. So you'll get there with it. It's just you've got to practice. Yeah. All right.